Okay, good day. We're going to answer your quiz number 2 in M106. Okay, this same doon sa kaninang video, it may or may not be the same given, pero the process is very similar to all of your quizzes. Okay? Alam niyo na yung reason kung bakit hindi pare-pareho ang mga given information sa bawat nagtitake ng quiz? Siyempre. Anyway, let's start. First, test 1, evaluate the limit of the following function. Limit of x squared minus 16 all over x squared minus 7x plus 12 as x approaches 4. If you will try table of values, for sure makukuha nyo siya. No? Dito. Let's use the algebra method para mas masanay kayo doon sa algebra naman. Let's use that method. This means we can factor it out as x minus 4, x plus 4, see x squared minus 16. And then the second one, x squared minus 7, x plus 12. Anong factor ni 12 na may sum na negative 7? That's equal to negative 4 and negative 3. X minus 4, x minus 3. Ayun. Cancel. We are left with x plus 4 all over x minus 3. Evaluate si 4. That is 4 plus 4 over 4 minus 3. 8 over 1. 8. Tapos. Okay, let's proceed with next item. Limit of quantity h minus 1 raised to 3 plus 1 all over 2h as h approaches 0. Okay, what we're going to do is we will expand this one using binomial theorem. Pwede yun, no? Yung a plus concept of a plus b raised to 3. Pwede yun, no? Magiging a cube plus 3ab a squared b plus 3ab squared plus b cubed. That could work. Or you can use the standard FOIL method. Regardless of that, we will end up with, kasi nga h minus 1 cube. So it will become h cube. And then this one is 3 times h squared negative 1 plus 3 h negative 1 squared plus negative 1 cube. And that's equal to h cube plus, minus 3h squared. This one is negative 1 raised to 2, which is equal to positive 3h minus 1. Kasi negative 1 raised to 3 is equal to negative 1. Plus 1 all over 2h. And that's equal to h cubed minus 3h squared plus 3h. Cancelled out na ito. All over 2h. You can simply factor out h. It's equal to h times h squared minus 3h plus 3 all over 2h. Cancel out h squared minus 3h plus 3 all over 2. And evaluate as h approaches 0. That's going to be 0 minus 0 plus 3 all over 2, or simply 3 halves. So 3 halves is the answer to this second item. Okay, next one. Evaluate the limit of the following function. Square root of r raised to 3 all over r minus 9 raised to 4. So that will be using fractional exponent, this will become r raised to 3 halves all over r minus 9 raised to 4. Okay. Which is the... Wait lang. As r approaches 9. Can we use algebra here? If we substitute directly 9 here, it's not going to work. No. So I don't think algebra is going to do much here. Or manipulating the function, simplifying it. Let's instead use a table of values. Pwede naman yan. So that will become value of r and the function f of x. Okay. 8.9, 8.99, 8.999, 8.9999, 9.0, 9.1, 9.01, 9.001, 9.0001. Find the value of f of x using calculator. Square root of walang r, so let's use x raised to 3 all over x minus 9 raised to 4. $8.9 265,512. 0.52. Let's see where this is approaching. 8.99. Oh, that's going to be a very, very large number. 269,550. 1,250. Let's try 8.999. Oh, it's a large number. 2.7 times 10 to the 13. That's in scientific notation. Let's see if it's raised to, or if the value of r is 8.9999. 2.7 times 10 to the 17. So you can see it goes up towards positive infinity. If that is the same case on the right side limit, that means the answer here is infinity. If it is not the case, no, if it goes on the other side, that means we don't have a limit at all. So we will try 9.1 274512. 0.48. 9.01. 270450. 1,250. What about 9.001? 2.7 times 10 is to 13. 2.7 times 10 raised to 17. So you can see they are approaching pretty much the same value from both the left side and the right side. That means the limit approaches or the limit of the function f of x is infinity, positive infinity. That would suffice. This table would suffice as proof that the limit of the function is indeed infinity. Next, number 4. Evaluate this function as the limit approaches infinity. Here, we can use the idea or the property of the limits approaching infinity, since numerator has highest degree of, what is it? 4. That is negative x to the fourth. And the denominator has the highest degree of what? 5, which is x raised to 5. Ayun sila. The limit of the function as x approaches infinity is equal to 0. So therefore, limit of f of x is equal to 0. That's how easy it is. Now we have discussed that before. If the numerator has a lower degree than the denominator, no? That means 0. If numerator is higher than the denominator, the answer is infinity. And if the numerator, the degree of the numerator, highest degree, is equal to the highest degree of the denominator, we have the ratio of the coefficients of the highest degree of each part of the fraction. Okay, so the answer here is 0. Next, number 5, evaluate the limit of the following function. Limit of 1 over x minus 1 plus 1 over x squared plus x plus 2 as x approaches 1. If we're going to substitute this, we will end up with 0. No, this 1 over 0, so it will not be possible. Okay, let's try algebra. Will this work? Is x squared plus x plus 2 factorable? X squared plus x plus 2. Factor of 2, which has a sum of 1. Is it factorable at all? The only factors here is 2 and 1. But it cannot be the case because it should be negative 2 to end up with positive 1, or the coefficient of x must be positive 3. Therefore, this is not factorable. Since it is not factorable, we cannot use algebra. We can, again, proceed. No, we can use a table of values. Let's use a calculator. 1 over x minus 1 plus 1 over x squared plus x plus 2. And then let's try values close to 1, 0.9. Okay. 0.9, 0.99, 0.999, 0.9999. And then let's try another one here. From the right side, 1.1, 1.01, 1.001, 1.001, 0001. Okay, that's equal to negative 9.73. Negative 99.75. What number is this approaching? Is this moving towards negative infinity, or it's approaching a certain number? Negative 999.75. I don't think so. It's not approaching a certain number. It is approaching negative infinity. See? It's negative 9999. Wait, let me try again. 0.9. Yeah, it's 9.73. Anyway, that's the answer. We are approaching negative infinity from the left side. So the limit of f of x as x approaches 1 from the left side is negative infinity. Let's find the limit of f of x as x approaches 1 from the right side by evaluating 1.1, 1.01, and so on. 10.23, 100.25, 1000.25, and 10,000.25. As you can see, it is approaching positive infinity. Therefore, the limit of this actual function, the entire function, does not exist because the limit from the left side and from the right side, the limits are not the same. They're not approaching the same value. They are approaching opposite values. In fact, one goes to the negative infinity, the other goes to positive infinity. So the answer here, the limit does not exist, or DNE for short. Next, test 2. Let's proceed to derivatives. This one is very easy. Let's just use the power rule for this one. Let's just multiply 3 x 3 minus 1 over 8. No. We can make this a little bit clearer by separating the fraction or the coefficient from the variable. So 1 8x cubed minus 2 over 9x squared plus 3x plus 1/4. And from this one, we can evaluate. This is f of x, and this is f prime of x. 3/8x squared minus 4 over 9x plus 3. And that's it. It's very simple. Next, this function, 15 square root of x plus 11 over x to the 4th. We will express these as fractional exponents and negative exponents before we derive. So this is 15x raised to 1/2 because it is square root, plus 11 x raised to negative 4 because this is from the denominator. G prime of x will become 15 over 2 x raised to 1/2 minus 1 plus negative 4 times 11 x raised to negative 4 minus 1, which is equal to 15 over 2 x raised to negative 1/2 minus 44 x raised to negative 5, which is equal to 15 over 2 x raised to 1/2 minus 44 over x raised to 5, which is equal to 15 over 2 square root of x minus 44 over x raised to So in some references, you may be asked to rationalize the answer, but for me, in my case, I will not require that. So this will suffice as your final answer. But if you need to rationalize, you just need to multiply square root of x to the both sides of this fraction, no, for this first term. Anyway, again, this will suffice as your final answer. Next, number 3. For this one, we will employ a combination of the chain rule and the quotient rule. We have a quotient here, 2x divided by square root of x squared minus 25. And then we have a function within a function, right? Because there is a square root inside the function x squared minus 25, outside rather. So in that case, we need to employ the chain rule as well. Let's use the product rule first. The product rule states that low d high minus high d low over low squared, or v du minus u dv over v squared, that's equal to square root of x squared minus 25. Now let's define first u, v, du, and dv. So we're not going to be confused in that with this formula. U is 2x, v, denominator is square root of x squared minus 25, and then du, dv, this will be simply 2, and this one, this is where we need to apply the chain rule, because x squared minus 25, square root of that entire expression is equal to x squared minus 25 raised to 1/2. So to find the derivative of this entire expression, we need to use the chain rule. That's equal to 1/2 times x squared minus 25 raised to 1/2 minus 1, which is equal to 1/2 x squared minus 25. No. Applying the chain rule, we need to find the derivative of the inside as well. So that will be 2x. Negative 1/2 multiplied by 2x, which is the derivative of x squared minus 25. This cancels out, so we are left with x multiplied by x squared minus 25 raised to negative 1/2, which simplifies to x over square root of x squared minus 25, because this is negative 1/2. So that's dv. So with that, we can now find the derivative of the quotient itself. Just plug it in. Square root of x squared minus 25 multiplied by 2 minus u dv multiplied by x over square root of x squared minus 25 all over v squared, which is equal to x squared minus 25 itself, because we are getting rid of the square root, because we squared the entire thing. Now, this is equal to 2 square root of x squared minus 25 minus 2x squared over square root of x squared minus 25 all over x squared minus 25. Now, how can we simplify this? We can multiply. This one is basically 2 square root of x squared minus 25 all over 1. So we can express this as 2 x squared minus 25 all over square root of x squared minus 25. Why? We have multiplied square root of x squared minus 25 to the numerator and the denominator of this fraction. Why do we need to do this? Because we have another one here, minus 2x squared over square root of x squared minus 25. So we can combine these two into one fraction. Okay? Then this one will stay the same, x squared minus 25. Then, combining these, we will end up with 2x squared minus 50 minus 2x squared all over square root of x squared minus 25 all over x squared minus 25. And that cancels out these terms. You will end up with negative 50 over square root of x squared minus 25 all over x squared minus 25. We can simplify this further so that we are only left with one numerator, one denominator, not just a complex array of fractions here. We can multiply this to the actual denominator of these entire fractions. So we end up with negative 50 all over square root of x squared minus 25 multiplied by x squared minus 25. And that will be the simplest form of the derivative of this function. So this will be the final answer for item number 3. Next, the derivative of the following function. Okay. For this one, we will also use the chain rule. So y prime or dy over dx is equal to 3 times... No. Before we convert that, let's express each muna into fractional exponents, no? So y is equal to 2 times x raised to 1/2 plus 4 times x raised to negative 1/2. This entire quantity is raised to 3. So with that in mind, we can easily find dy over dx using the power rule. So, and chain rule. Chain rule here is because the entire function is raised to 3. So we need to apply the chain rule to evaluate that one. That means we end up with 3 times 2x raised to 1/2 plus 4 x raised to negative 1/2 raised to 2. And then find the derivative of the inside. That means we have 1/2 times 2 times x raised to 1/2 minus 1 plus negative 1/2 times 4 times x raised to negative 1/2 minus 1. That simplifies to 3. Copy this one. This will become cancelled out. X raised to negative 1/2 plus, or rather minus, kasi may negative doon, minus 2x raised to negative 1/2 minus 1. That's negative 3/2. Okay, next. We're running out of space. Okay. This will be 3 we can bring back now the negative exponents here. This will be 3 times 2 square root of x plus 4 over square root of x raised to 2 multiplied by 1 over square root of x minus 2 over x raised to 3 halves. Actually, at this point, I will accept as the final answer. As long as you can, you apply the chain rule and this one. No. However, some references may require you to expand this entire thing. This one is squared, but I don't require it anymore. If you get to at this point of the solution, I will accept your answers. Okay. Let's proceed to the last item for test 2. This one is the easiest one for derivatives, actually. So to simplify this first, this is y equal to actually it's just multiplied, so we can simplify this as 26x e raised to x over 2. It's the same. We can swap the place of 26 and x because multiplication is commutative. So we end up here with y is equal to 26 over 2, which is equal to 13 x e raised to x. And to find the derivative of this one, we will apply the product rule, which is u dv plus v du. So in this case, u is 13x and v is e raised to x. So 13x du, du first. Du is 13 and dv is e of x. It is e raised to x rather. 13x times e raised to x plus this one is e raised to x times 13. So we end up with 13x e raised to x plus 13 e raised to x. And this will suffice as your derivative actually. Though you can further simplify this. It's the same either way. 13 times x raised to x times e raised to x plus e raised to x, which is the same actually. I will accept both of these answers. Okay, we're down to our last item or for test 3. This one is a very easy application of derivatives. There are lots of applications of derivatives. Meron tayong rate of change in volume, surface area, etc. But we were only able to touch the concept of motion, velocity, and acceleration. So let's recall again the position. The derivative of position is velocity or speed. The derivative of velocity is acceleration. Usually the variables used here, this is s, this is v, and this is a. So in this case, we are given the equation of motion denoted by s, which is the equation of the position of the particle. So to find the velocity of the particle after 9 seconds, we need to find the derivative of this function and then evaluate at t equals to 9. T is equal to 9. So this will become 3t squared minus 22t 22t plus 20. 3t squared minus 22t plus 24. And simply plug in the value of 9. No, so v of 9, actually v of t. Ayan. V of 9 is equal to 3, 9 squared minus 22 times 9 plus 24. So if you're a bit lazy to do the computation, you can use a calculator here. It's 3 times 9 squared minus 22 times 9 plus 24. It's equal to 69. So V of 9 is equal to 69. The answer here is 69. Velocity has the unit of feet per second. So feet per second. That's the answer. For the next one, we are looking for the acceleration. The acceleration of this particle is denoted by the derivative of its derivative, or the double derivative. So we will derive this one. No? So we will end up with 60 minus 22. And simply substitute 16. T is equal to 16 in this case. So A of 16 is equal to 6 times 16 minus 22. So you end up with 74. 74. It's equal to 74. What is our unit in this case? The unit here is feet per second squared, because we're talking about acceleration. So that is our answer for the two items A and B. So that will earn you 10 points in total. And that concludes your quiz number 2. So if you have any questions, feel free to ask me in the chat, in Messenger, or via Teams. That's all.